treasure of women. We fall into the galaxy of intellectuals. I, Shivani Kush, on behalf of Academic Outreach and New Initiative Office, under the able guidance of Shilpi Ma'am, our Associate Dean, extends a very warm welcome to the distinguished faculty, teachers, management, and to my dear students. We are thrilled to host our fourth session of Sci-Tech Spins Lecture Series, an initiative of the Academic Outreach Office, IIT Delhi, which aims at enriching the educational experience of high school students. In the class, the beat is tight. Professor drops wisdom day and night. Rhythm flows from mind to beat. Learning dances on your feet. It brings me immense joy to extend a warm welcome to our eminent speaker, Professor Deepak Jain from the Department of Optics and Photonics Centre at IIT Delhi. Well, we welcome you, sir. It is my privilege to introduce you all to Deepak Jain, who is an assistant professor at the Optics and Photonics Centre of the IIT Delhi. Before this, he was an assistant professor at the Electrical Engineering Department of IIT Bombay, a university research fellow at the University of Sydney. He obtained his PhD from Optoelectronics Research Centre, University of Southampton, UK, and his MTech from IIT Kanpur. His area of interest revolves around light, its application, technology, transformation from academia to industry. He is the founder of Deep Place Technologies Private Limited and the Brahma Sense Corporation, a Delhi-based sensor and laser companies. He has more than 70 publications, including 31 journal publications and several invited conference papers. He is an Optica ambassador and also senior member of Optica and IEE. Recently, Deep Place won prestigious IDEX Aditi 2.0 grant worth 25 crores. Now I would request the Professor Deepak Jain to come on the dais.
And many thanks to the outreach department, Shivani ma'am, Professor Shilpi Sharma, and other colleagues and our IT team members for organizing this lecture. And it's an honor to be here. Screen. Display bhi aayega. Thank you. Thanks a lot. So today I will be talking about future in making, power of science, innovation and engineering. Believe me, I won't let you sleep in this lecture, and this is going to be very different from what you have in usual days, okay, in your school days. So today we'll talk about the impact of science and technology. I will give you some examples. Of course, it is not possible, or at least some episodes of that. So that will help you in translating your ideas into a product. At least that will give you a roadmap and that will tell you something about how it happens. And in the last, some generic tips. If you want to be a good innovator, entrepreneur, scientist, or if you're looking forward for a future in science and technology. Okay, so let's start with science and technology, the engine of growth. Okay, let's have a look at this map. I'm sure most of you will be able to recognize it's the world's map. And the black color indicates the countries which were under the control of British Empire. I won't talk about the bad things of that empire. Of course, there's a big history of that, but let's talk about something good. Let me ask you one question. What made British to win the almost entire world? Almost 25% of the world's earth was under the British control. This sort of empire never existed in the history and will never exist in future, right? Anyone would like to answer? What made British to win the whole world? Anyone? Yes, please. Navy. Okay. Anything else? Thank you. Yes, please. Technology. Thank you. That covers both the answers. Basically, the vessels, the weaponry, the engines, they were far ahead of the rest of the world, and which made them to win the entire world. Now let me talk about another story of the South Korea. How many of are you using LG, Samsung, Hyundai, Toyota products? Please raise your hand. Almost everyone in this room. And isn't it a matter of shame, the country which got independence in 1945 from Japan had a black history of Korean Civil War, And of course, it was not a democratic country, and it like became democratic in after 1987, and it's still far ahead of us, selling all their product to us, much smaller in size. And if you see, they're the 5th largest exporter in the world, 8th largest importer in the world. Basically, they export more than they import, and still in India we import more than they export. So why? Because there's a lot of focus on science and tech. Let me just tell you a little story about South Korea, the leadership. Okay, when India and Pakistan got independence, then there used to be the war tax for the Second World War. British used to charge a second war tax from the Indians and the Pakistanis, or I should say all Indians, to contribute to the World War. And this task used to be done by the municipal corporations in local areas. And when British left, in somewhere in Pakistan, some money was left, which was supposed to be taken by British as a part of the tax. But then the municipal corporation thought, okay, what to do with this money? Let's send some people to Cambridge. They organized some scholarships. 10 students were sent to University of Cambridge. One of them did very well there. There used to be, at a time, BA in science, okay? And he did very well. He got further scholarship. He did PhD. And the name of that chap is Abdul Salam. He won the Nobel Prize in physics. And it was the first Muslim ever to win a Nobel Prize, and the first Nobel Prize that went to the Islamic world. And when he returned to Pakistan, South Korean government approached that we want Abdul Salam to visit South Korea to deliver lectures in our universities and schools. Then Pakistani government said, why? You are so advanced in technology. Why do you want our scientists to visit South Korea? Then the South Korean government said, see, we are good in technology, but we are not that good in fundamentals. Abdul Salam won the prize for the particle physics, if you know. We want him to come and visit, and it will inspire our young people to pursue fundamentals as well. So this is the vision, basically. Now let me give you one more example, story of polio. And I'm sure the young chaps I can see here, they have been through this corona, right? And you have seen the impact of that epidemic, pandemic, or whatever you say. So polio was a big problem, huge problem in 1930s, 40s, especially in the United States. It used to have a wave during summers. Basically, it used to impact the children, and either children used to get disabled or die, or like very rare, they will just be able to survive. So Winston Churchill, who was the, at a time, it was a big problem, so there was no solution. And then the American government thought, okay, we will just somehow will find a solution for this problem. A team of virologists were called. Those virologists are those people, those who study viruses. And at the time, there was a very limited understanding of polio viruses, what kind of viruses it is that. It was just known that it's a viral disease. Then 2 teams were formed. One was a young PhD, Jonas Salk. Another was Professor Albert Sabin. And both the teams independently worked over this problem. And at the end, they could identify what are the viruses. Then there were the different opinions, whether should we vaccinate the people with like died virus or with half died, basically. Then different approaches were tried, but at the end, they found the solution, and now we know that polio is almost gone. And when Jonas Salk was asked, would you like to patent this medicine or this vaccine? He said, there's no patent. Can you patent the sun? So that's the motivation. If he would have patented this vaccine, he would have made billions, trillions, but this wouldn't have reached to all of us, right? Some of us would not have been here. Some of us would not have been in the right shape. So that's the vision, basically, and that's somehow you can say the vision of the leaders. The hard work of the young people helps to build the country. Now let me tell you one more story about the Bell Labs, okay? A cradle of modern technology. All of us are using internet, smartphones, chips, right? From where it comes, basically. Is there a single answer that who invented the mobile phone? No, thousands of people contributed it, whether it was Maxwell who derived Maxwell's equation, then the Hertz who first demonstrated the electromagnetic waves, then the Marconi, and many more. So Graham Alexander Bell, after the invention of his phone, was granted a big chunk of money from the France government, and then he decided to set up a lab named after a great scientist, Walt. So Walt lab was started at Murrah Hill in US. And then it became a center for like scientists, whosoever used to do a PhD, irrespective of the location and geography, used to come to Bell Labs to contribute. And this is the place where everything almost in electronics, whether it is diode, whether it is transistor, whether it is MOSFET, the integrated circuits, the chips that you see in your phone, microprocessors basically, were invented there. Okay, and you can see the picture of the John Barden, William Shockley's equation. I'm sure those who are in class 12 must be studying about semiconductors and must be aware of this diodes, transistor, etc. 9 Nobel Prizes were awarded to the Bell Lab scientists, okay, for groundbreaking work, whether it is computing. C, the language, programming language where most of the games that you play are written, was invented at Bell Labs by Dennis M. Ritchie. Okay, so the idea of forming a center of science and tech, you can see the contribution which it made to the mankind, and it changed the way we talk, the way we see each other forever. And the most important thing through which we all are connected, and during the pandemic we saw the huge impact, of course, the story of internet. Nobel Prize 2009 was awarded to the Charles Kao for inventing optical fibers. I'm sure you must be having broadband connection at home, the black fiber cable which comes with that, and if you avail a connection, the guy will come with a big box and the black cable. That black cable is optical fibers. So internet, the optical fibers are the basis of, or you can say the backbone of the internet communication, which has a glass. Basically, optical fiber are made up of glass. Anyone have any idea why the optical fibers are made up of glass? Okay, no worries. So this is not an electric current, this is light, okay? And if you see, light need a medium to travel, and the glass is a medium to travel. If you see the window pane, light can move from other side to here. So if we can make wires of glass, that will allow light to travel along the wire. So optical fibers are made up of silica glass, but in 1950s when they were first invented, they were not very pure. They had a lot of impurities. So a young Punjabi Sikh, Narendra Singh Kapane, went to Imperial College with Professor Hopkins, where they first thought of using optical fibers to transmit the images. Okay, so it was not as simple like your generation is well blessed that day one you are using internet, the day you are born your pictures are being sent. But the first picture which was sent, the distance was 75 centimeter, and the man behind was Narendra Singh Kapane at the time. And things were not that simple as it is now. But then Charles Kao moved from Hong Kong to UK, and then he thought if we can remove the impurities out of this glass, the distance of these fibers can be much, much larger, and the pictures can be transmitted over a far long distance. So he spent entire his life doing these optical fibers, and in 2009, he was awarded the Nobel Prize, and he was so not in a good shape at the time that, but his wife came to receive the Nobel Prize. So it was not that easy. As I said, like in 1950s, the idea was conceived that we can send images through fibers. Like basically this fiber acts like a waveguide. Suppose there's a big reservoir of water and you want to take that water to your home. So it has to go through water pipes, right? What water pipe does? It guides the water. Otherwise, water will go in all the directions. So some properties that it need to fulfill, like in water pipe case, it has to be made up of a material so that over a period of time it won't corrode, right? It will sustain the water pressure and all those things. So similarly for the optical fiber, like it should be able to guide the light. Light should not be leaky. If light would be leaky after traveling a distance, light will disappear. And light should be able to modulate whatever information. For example, right now I'm speaking, it can be converted into electric signal, and light can be modulated according to that, like impose of the information on the light. Okay, so the fibers were very lossy, like they were not good enough for the long distance communication. Now the whole world is connected through optical fibers, right? And a few years before we had, to give an example, like undersea cables from Chennai to the Port Blair. Before that, there was no broadband connection Port Blair in entire Andaman. Okay, so first cables were like in 1970, 20 dB per kilometer. If I'm not sure how many of you know what is dB, it's a unit of loss. So initially the losses were very high, like almost entire light used to disappear after a kilometer distance, but later on like processes were developed at Corning Corporation in 1970, and these three young gentlemen, Kack, Muller and Schulz at the time, like during their postdoctoral studies, invested a lot of time and developed the first low loss fiber, 20 dB per kilometer. Afterwards at NTT Japan, it took 8 years to develop 0.2 dB per kilometer. See how technology develops. So it's not the one person who contributes, it's a continuous process of developing things. inch by inch. And you see the Peter Schulz, the old Peter Schulz. This picture was taken last year. I invited him for a seminar. He was awarded the US National Medal of Science and Technology, highest medal in United States for the contribution in science and technology. And after 1978, in 2017, the best loss was achieved again by the Japanese, and it is 0.149. So almost technology has saturated, right? So we are seeing the best time for the optical communication as of now. But life doesn't end if you still want to pursue in this career of internet. Now the challenge is that how we can send more and more data. So I won't talk about that, that would be too technical, but that is known as a space division multiplexing, where you can send more and more data because there's a huge demand for communication. If you ever visit a data center, you'll find it's a jungle of optical fiber basically. And almost 4% of the world's electricity today is being consumed in the data centers. So that is quite interesting basically. Now another example that I would like to give you is about blue light emitting diodes. LEDs right now we have in these rooms, and Nobel Prize was awarded to three Japanese scientists, including Hiroshi Amano, Sujiki Nukumara, and Ishamu Akashiki. I had an opportunity to meet Hiroshi Amano once. So what they did and why did they were awarded the Nobel Prize? So see, if you see this picture, the initial sources of light were oil lamp, then we moved to the light bulbs, then the fluorescent lamp, and now we are using LEDs. And if you see, if we spend 1 watt of power, how much lumens of light we can get. If you're not aware of lumen, forget about it. You can just see from these numbers, like tremendous progress, right? Isn't it? If you're spending 1 watt, you will get 70 lumens. If you spend 1 watt, you'll get 300 lumens, almost 4.5. So this was the reason that they were awarded Nobel Prize, because they invented one specific color light emitting diode. Before that, we had already light emitting diodes which could emit light in red and then green. If you combine red, green, and blue, you will get white. But for a long time, there was no semiconductor which could emit in blue. So there was a long race to develop gallium nitride, where semiconductor and hole combines, they emit light in blue. So it took a lot of efforts across the world. People were trying to grow the optical quality gallium nitride, which could emit in the blue light. And the combination of this would have been given the white light. And if you see in terms of impact, so if you read this line, with 20% of the world's electricity used for lighting, it has been calculated that optimal use of LED lighting would reduce this to 4%. Okay, so that one gain of 16%, that's huge. So this is how Nobel Prizes are awarded for the bestest benefit of the mankind, basically. So I've given you two examples, like internet and and the blue light emitting diodes. And of course, it's huge, like the example of polio and example of Bell Labs, South Korea, and the story of the British Empire. Now, okay, that's good enough to be motivated, I believe. And if you see, the most important thing in my life, what I've learned, that is to have a dream, okay? It is very, very important, right? If you have a dream, if you have a vision, then only you can do something big. If you don't have the vision, if you don't have the dream, you won't be able to do big things. And that makes the whole difference, okay? So you have to start thinking from now. You should have a vision. Okay, I am going to do this. And that should come from your inner core, not from the influence of your parents or from your friends or your relatives or whatever else is doing from the social media or whatever. You think what you want to do. And if you don't want to do something for yourself, then do something for the country. That is very, very important. See, it's our responsibility to fix our country. We are proud of that. That is in United States. Google CEO is this, Indian and all that. It doesn't matter. Until and unless we won't fix our country, we won't get respect in the Western world. And we have to accept this one, and it's our own job to fix this country. Okay. So one shortcut is to run away, go abroad, which is very, very popular nowadays among the youngsters, but that won't help. Okay. So let me show you some examples and how, I know it's too early at this age, but still age is just a number. Nowadays, even we see startups coming from the school students as well. And of course, I don't mean that you do a startup right now, but I'm just showing you a roadmap, how it can help you. That's up to you, like how do you utilize it in future. So the question comes like, while you will be doing your, let's say after finishing your schooling, BTech, MTech, MSc, whatever you have thought, BSc, MSc, PhD. So why one should opt for a startup? What startup does basically, right? Nowadays you keep hearing this company did that, unicorn, right? what they do, basically they solve the problem. Okay, if you solve a problem and which you can't solve yourself and you hire someone, then you pay. Okay, suppose you want to go your home from IIT, you need a cab, and cab will, you have an app, you will book a cab, the person will come and will take you. So that's a problem. Like how to go, may I have some water please, if possible. So how to go from here to home, that's a problem, and that problem can be solved by this cab. So that's why you are paying money. So startups are looking to solve a problem which has not been solved, or if it has been solved, it has to be solved in a better way. Let me give an example, like why Ola and Uber are so popular or so successful. Anyone? Taxis were there, cabs were already there, like it's not something new. But why they are so successful now? Yes, please. Is that the only reason? Like when I was of your age, we could call and taxi would come to our place. Anyone else? Yes, please. Okay, comfort, convenience. Anyone else? Yes, please. Competitiveness. Yes, that's very important. Okay, thank you. So, Ola is a model of replication of Uber. And when Uber was doing this customer survey, approaching people like, what is stopping you from booking a cab? So they learned, of course, all these feature matters like convenience, comfort, getting cab at any time. But the most important factor was the price. Okay, suppose if I am going from here to X place, I can see the price. If I can afford, I will go for it. If I can't afford, I won't go it. I trust, okay, the price would be somewhere like this much. So this was the problem. Problem was not the cabs. Cabs were available, but problem was that people were not trusting these cab companies, were not able to trust the drivers that how much they will charge, whether they will follow the right path or not. Okay, so this was the problem. They identified it and they solved it. During startups, you will be selling your ideas to investors. That is the most important thing. So you need to bring money. And if you are good at presentations, like, of course, this presentation has been made for the PhD students, but wherever you see an opportunity to present your work during your school days, whether it is declamation, debate, that will make you a leader. Thank you, man. Thanks a lot. So that will make you a leader, because at the end, it doesn't matter whether you become a professor, whether you become a CEO of a company, whether you have your own startup, you have to talk. You have to talk in front of people. You need to know how to make presentations, how to defend your ideas, how to sell your ideas. So this is a very good time while you are in school that you do participate in all these extracurricular activities. Proposals for proof of concept, minimal viable product, business plans. You need to write business plans, you need to write proposals that you want a limited money for developing a proof of concept. Proof of concept is like if you think some idea, you do a little demonstration for that, a minimum viable product basically. So you need to have good writing skills. Of course, ChatGPT is there, and by the time you will be of like college or you will be working, you will have more advanced softwares, but still writing is quite key, very, very important. Even if you write through ChatGPT, if you have seen the right articles written through ChatGPT, they are not having emotions, right? And if you are good at expressing your ideas, so you can fill those ChatGPT articles with emotions. You can put your emotions into those articles. Like if you smartly use ChatGPT, it's good, and that is one way of your writing skills. Perseverance, it is very, very important. See, in life is not fair. You will have a lot of rejections sometimes for XYZ reasons. So, but keep working hard. It doesn't end. I'm sure most of you must be preparing for JEE, or if you are not preparing for yourself, like you must be forced by others to prepare for JEE. It is going to be very, 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 very competitive, but it's not end of the world. Let me tell you, being very, very honest. If you clear, that's fine. If you don't clear, that is also fine. And let me tell you a little story about JEE, because we just started discussion, and that is more relevant to you basically. So in 1996, my cousin brother cleared IIT JEE. He had 115 rank. And at that time, I used to stand first in my class, and I used to think the world is like that only, up to my classroom only. And when we heard 115 rank, I said, 115 rank? What is this rank? It should be 1. When I will write this exam, I will get first rank, okay? I wrote JEE, I didn't qualify, but still I'm a faculty at IIT. Maybe I'm outperforming than, I should not say, but just to give an example, than others, those who qualified JEE in my life. But this was always a problem, always a depression for me that I didn't clear JEE. Why? So when I was doing my PhD, I had a colleague who did BTech from IIT Delhi, a 3-digit rank. So being Indian, we used to live together in a house as a PZ. So what I found, like what made him to clear JEE, that suppose if I'm doing an experiment, some experiments are very, very difficult, especially if it involves infrared light. I'm from optics background. So my threshold was 4 or 5 hours. After 4 or 5 hours, I will give up. I need some tea break or something like that. But his threshold was 8 hours. Continuously, he will tuck, 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 tuck. This made him to clear JEE. JEE is about solving questions in limited amount of time. But world is not about just that. Okay. See, I have to select in 3 hours of exam and number of students. Then I have to like bring a mechanism, which is fair enough, right? There's a pressure on me to select people. But in real world, there's no such pressure, believe me. So now if I compare Mr. X and Y, who had a threshold of 6 hours, and the other who had a threshold of 8 hours, but there were other skills as well, like communication, vision, networking, talking to people, raising money. Those are not being checked through JEE. Those are different skills. Okay, that's why you see those who clear JEE doesn't mean that they will also clear UPSC. Those who clear UPSC doesn't mean that they will also clear CAT. Okay, so these are different exams, and irrespective of these exams, I have seen people doing very, very well in their career despite clearing all these exams. So whatever you decide to choose, it's okay. Try your best. If you clear, that's fine. If you don't clear, just think that these are some skills that this exam is looking for. Possibly I don't have those skills, and I may have those skills in futures. Okay, just to give an example, like when I was selected at IIT Bombay as a faculty, and in Photonics division, I had 4 or 5 colleagues, those who were working in the similar area. One was, I don't want to mention names, 2-digit ranker in IIT JEE, classmate of Bhavesh Agarwal, the founder of Ola. Other was from IIT Kanpur, 3-digit rank. Other was BTech from IIT Madras, junior of Vinita Singh. Most of you must be knowing Vinita. So I was thinking, will I be able to survive with these people? But I survived, okay? And in fact, I'm doing a bit better. So the reason is that in long run, perseverance matters for how long you can perform, for how long your motivation remains. Long-term vision matters. And if you don't qualify JEE, it's okay. Like you didn't have that skill, that's it. But you may have other skills, many other skills. So don't punish yourself. And the world is quite big. There you will get many opportunities, but keep working hard. Opportunity may come at any point. So you just grab that opportunity. So perseverance is very, very important. Risk handling. If you do a startup, of course, it comes with a risk. If you do a PhD or research, career of researchers have a lot of risk, basically. No worries. But you learn how to handle those research. Okay, let me give some ideas where the lab inventions have been translated into a product. Okay, so one of the example is Vitricity, wireless transmission of electricity. We know Wi-Fi, but Vitricity is not that common. But when I was doing my BTech, I think in 2007, it was invented, Vitricity. Okay, so here you can transmit electricity without any wire. That's why the name is Vitricity. So this was invented at MIT by Professor Marin Solovich group. Here you see 2 coils, okay, without any connection. You can see these gentlemen sitting in between these coils, and you see the bulb is glowing. Okay, that's a very clear demonstration of wireless transmission of electricity. Then they converted into a company, Vitricity Corporation. If you want to do a Google, you can do Google about Vitricity Corporation. And it has a lot of application. One is in e-vehicles. We are not talking about e-vehicles, so you can charge your car, you park it. But of course, wireless efficiency won't be that high as with the wire. The other example is charging of the pacemaker inside the human body, which needs wireless charging. So there are many, many examples. It's a successful company. They're doing very, very well. So a small idea which was invented in the lab or thought in the lab has been converted into a product, and it's a company now. If I talk about another examples, Li-Fi, if you have heard of that. So in Wi-Fi, you use the radio waves. In Li-Fi, you can use the light to transmit the data, basically. Li-Fi, you maybe beyond any doubt, like after 5 years, you will have Li-Fi at home. And this was taught by Professor Haas at Edinburgh University in UK. And Li-Fi is 100 times faster than the Wi-Fi. Deepak Solanki, an Indian guy, he's leading this company, Wellmanai, working on that commercializing this one. So if you see in terms of invention, usually invention comes at the university place where people work over it, bring it to a level, then company picks up the idea, they work hard over it, and they translate into a TRL level, technology readiness level to 7, 8, 9. You might say these are examples from the Western world. Okay, MIT, these things happens in United States, very common. But let me give you some example from my own life. So when I was doing my postdoctoral studies at Technical University of Denmark, my supervisor thought, okay, let's form a company, Noblis, which is Nordic Broadband Light Sources. I won't go into the detail of the light sources because it will be too much technical. We started like 3 research fellows, including me, and 1 professor. So we raised around 500,000 Danish krone, which is around 50 lakh rupees as a soft money. It's a reality. You can do a Google about Noblis. There, I learned that it is possible to do business using others' money. Don't worry if you don't have the money, you can use others' money to do the business. And that's always the best strategy. Okay, gone those days when people used to have their own money to start a business, okay? So while I was at Sydney University as a postdoctoral fellow, I had an idea which could change the shape of the beams, laser beams. If you have ever used a laser as a pointer, you can see it has the highest intensity in the center and then it gradually goes down. But if you use lasers for material processing, it has to have a very flat one. So beam shaping fibers are required. So I thought of this idea. I approached the university that I have this idea. Can I raise money? Can you give me some money to do the experiments? Okay. We filed the patents, and I will talk a little bit about patents later on. Patents protects your invention, basically, being exploited by others. If I have an idea, if I have patented this in India, no one else can use that idea for commercialization, basically. And unfortunately, there's no international organization which gives international patents. You have to file patents in individual company. And it takes a lot of money, again, but you don't need to worry. Nowadays, there are a lot of accelerators in the country. You can approach them, okay, I have this idea. They will file patent on your behalf. They will get some equity out of your company. And they do give some money, just like I got it from the University of Sydney to make a prototype for that. And then you look for the customers. Okay, so after moving to India, I and another faculty in civil engineering, we thought of let's form a company, Brahma Sense. So Sumit is a faculty in civil engineering. He's BTech from IIT and from UC Berkeley, he did his PhD. So as you can see, there's no combination between optics and civil, right? He is a civil engineer. But they were using optical fibers for sensing, and I'm an optical fiber expert. So this is how you see the interdisciplinary solutions for the problem. So you need to do networking. You need to talk to the different experts out of your domain as well, because the nature of the problem is interdisciplinary and the solution is also interdisciplinary. And also we formed another company, Deep Lays here, which makes lasers, very, very high power lasers. Lasers, as I said, can be used as a pointer, but if you increase their power level, they can be used to remove the hairs. In cosmetology, if you increase their power further, they can be used to treat many disease like lithotripsy. You must have heard Durbin wala operation, that is basically optical fiber and lasers. And if you increase their power level, they can be used in material processing. If you see the screen of your phone is so smooth, that is being achieved with lasers. And if you increase their power level further, they can be used as a weapon to counter the drones or aircraft. So that's basically our goal. Recently, we got for our work some award from DRDO, and we are looking forward to develop 10 kilowatt lasers as a weaponry. So anyways, after giving you these examples, the idea is that do you want to fix someone's window or construct your own windows? I'm giving an example of window here because most of the jobs are from IT sector. Irrespective of the degrees, people end up doing job in IT. Or whether you want to have your own company, let people work for you. Country need that. We need entrepreneurs. We need companies. Normally the question comes, do I need an MBA degree? Okay, and there's a lot of craze. You must be seeing your elder cousins pursuing MBA and everyone doing almost MBA, who is craze for MBA. But the question is that 20 years down the line, there's hardly any MBA degree, right? Like I don't know any of my uncle had an MBA degree, but still having good businesses. So I asked this question to someone in Denmark when I was doing my postdoc. He said, no, as long as you can keep this formula, profit to be greater than 0, you don't need an MBA degree. And believe me, you won't learn that much as you can learn while having a startup. Even a failed startup, if you do something, let's say for 2 years, if it doesn't work, that can teach you more than what 2-year MBA will teach you. So that's the answer. So how you start a business basically. First is the motivation. There has to be a motivation. And motivation comes, of course, from your inner side. Motivation comes from the success stories of university startups, from ECRs. If you're spending time on your social media, then look for the channels which talk about the motivations, okay? So see, for motivation, it's like, it is also important to keep yourself motivated, right? It's very, very common to get frustrated. So read about the success stories, watch biopics. That is a very important way. Then second comes the important ideas. If you see, look for the solutions, ask questions. That is very, very important. There is a Nobel laureate, Sir Timothy Hunt from UK. He was awarded Nobel Prize in 2001 in physiology. I asked him, what's the secret of winning Nobel? He said, just ask questions. Ask questions to yourself, ask questions to anyone, until unless you have got a convincing idea, okay, yes, I'm convinced now. So during this journey of asking questions, looking for problems, you will find some solution, okay? It may be too early to file a patent, but once you are in your college days, or let's say while you are pursuing your research or whatever, or it can be even at this age, doesn't matter, you file a patent. A little bit about patenting you should know. There's a provisional patent where you inform a patent office that you have made an invention, and patent office will keep it with them, like they won't do anything. But meanwhile, let's say during next 12 months, if I file a patent and if I ask for a patent to the patent office, then they will look at it. If they have submitted anyone else has submitted the same invention as a provisional application, okay? Then PCT, Patent Corporation Treaty, it's a treaty of 180 plus countries where you get some feedback, you get 18 months. Provisional patent gives you a 12-month time width, PCT gives you 18 months, and then you can file for the national phase applications. Patents are just about business. They can make you billionaire if you file the right patents, and if you don't file the right patent, you will be in problem. Like you will have a lot of competitions, basically, especially from big companies, because once they know, okay, this idea is working, they have more money than you, they will just fuel it, okay? And team building, I will skip publication, that is more for PhD students. Crazy co-founders, you need team, you need people with having different skills. It can be your friend, it can be anyone. So wherever you see an opportunity, this person is good with this skill, form the network. See, if you have the right network, that can be very, very helpful, okay? Being in the right company. Raising funds, there are two kinds of funding. One is soft, one is hard. Soft funding is the money which you are not supposed to return. It can be in form of award, it can be in form of equity, like in Shark Tanks you see. You sell 1% of your company, 2% of your company, you get money. You're not supposed to return that money. So that's very safe in the beginning, right? It's a high-risk startup, new company, which you don't know whether it will run or not, but you get the money for free. Then, and you may ask me, like, from where these people, why do they invest, right? See, these people have, like, these are HNIs, high net individuals, maybe 10,000 crore, 20,000 crores. They are looking for 10x of their investment, not like 1%, 2% or 5%, like 10x. So they invest in n number of companies, 10% of them will do very, very well. They will change the money like maybe 100x rather than just 10x. Some will not do that well, maybe 2x, 3x, and some will fail. So on an average, they will get usually 10% return. That is why they invest in the companies. Then comes the hard funding, and nowadays government is also pushing. Like I'm sure you must be having Atal incubation labs at your schools, and they are also giving grants, small grants, 2 lakh rupees, 5 lakh rupees. Like Ministry of Electronics and IT gives 5 lakh rupees. Type 2 program is there. We have a RI Park here at IIT Delhi. And hard funding is the funding, typical funding where you give basically a loan, you have a collateral damage, you have to return that money basically, okay? So that's a bit hard, but that you can have later, in the later part of your company where there's a less risk, you know the money will come. Product prototyping with validation, it is very important once you have an idea that you make a prototype. I know you may not have the right amount of money to make the complete prototype, but even a small prototype is very, very important. Customer survey and discovery, this is very, very important that maybe you are trying to solve a problem which has already been solved by someone. You may not know about your competitor, and someone tried and failed, okay? So as a researcher, as an inventor, it's fairly common to fall in love with your invention, but believe me, customer survey and discovery is very, very important. Companies, those who are very successful, they did customer survey and discovery well in advance. Okay, then comes the company formation, accelerator programs. If you don't know how to do that, then there are many accelerator programs in the country where you go and join for 6 weeks, 12 weeks, 3 months, sometimes 6 months, like Vadvani Foundation is there, they have their accelerator program. There are many these days where you learn basics of the business, where they also give some little bit money as a proof of concept. So hard funding, soft funding, I already talked about that. loan from bank, VC, capitalist, angel capitalist, soft money is the free money, government money. Blue ocean market versus red ocean market, if you are inventing something new, where there is no competitor, but no existing market. Suppose if I want to start a company manufacturing laptops, yes, there is a market. We know that it's a huge market, but already there are competitors. So you'll be competing with the giants. But if I come up with some new product which doesn't exist, okay, then there will be no competitor, but there is no existing market as well. I have to make sure that whether the market exists or not. Market search, how you do the market search, like how do you find whether it's a market fit product or not? You conduct surveys, you use Google form, ask people to fill in. You must have seen the movie Padman. That's another example basically. Interview your potential customers, need to know. See, as in the beginning I said, startup is about solving a problem. So you need to interview your potential customers, like what are the problems they are facing, their pain points, and this is what you are going to solve. So that is very, very important. Okay, I already talked about the Uber. Minimum viable product is important. If you go to investor, if you show, okay, this is something I have prepared already, that makes a lot of difference. Pitching, like in pitching, you talk about what problem you are solving without going into the detail of physics. If you are a like deep tech entrepreneur, then the market size opportunity, because they want to scale their money. As I said, 10x. So they want to see if the market is that big. If market is not that big, they won't be able to scale. Okay. Description of your product, sales, distribution, revenue model, competitive landscape. I think you already had many, many examples of pitching during Shark Tank, so I won't go into that. VC firms, there are a lot of VC firms. Recently, we were trying to raise money. We found that people are ready to give you money. There are more VC firms than the people seeking money. If you have the right idea in this country, you can get easily the money. If you have the right entrepreneur, you have the right courage, good vision, then you can raise the money. Okay. Now, if you can't raise, then the other idea is the crowdfunding. There are a lot of websites these days where if you are mission-oriented startup, where you want to do something which you think is good for society, you can go to these websites, you put a case that I want to raise this much money, people will donate, okay. And I talked about accelerator programs. Some of these are from outside India, but some of these are in India, like India Accelerator, HACS, Safal, a very, very important one, Acceler, GSF Accelerator. So, and there are many equity-free grants, seed money, SISF, okay, Startup India grant, which is for 20 lakh is nearly free. It's a matter of applying, you will get it. Up to 50 lakh if you share some equity. Methi Startup Hub is there, and where you get tied to initially without proof of concept 4 lakh rupees, after that 7 lakh rupees. Niti Aayog, Atal Innovation Mission. BERAC is a very good source of funding if you have ideas related to biotech, medical. IDEX is a very good if you have ideas related to defense. They allow anyone, even a single innovator can come forward. You visit their website time to time, they ask for they float the challenges basically. Aspire Mission, Telecom Tech Development Fund, many others. Now the question comes, maybe you are too little early, like how do you prepare yourself for entrepreneurship basically? So I'm sure you must be being given this advice that a picture is worth of 1,000 words. Please draw pictures during your exams in answer sheets. When it comes to business, a prototype is worth 1,000 meeting. If you can show your prototype to the investor, it is worth of 1,000 meeting. Similarly, I say that apply for scholarships and fellowships at this young age. Wherever you see an opportunity, apply for it. See, doesn't matter if you become director of a IIT, CEO of a company, or an inventor or XYZ, you need money. You need to raise money. Leaders are supposed to bring money to the company. As a CEO of the company, you will be bringing money, you will be bringing customers. So you need to learn how to win the money. That will make you a good leader if you know how to win the scholarship. Doesn't matter, even if you have the money, but apply for the scholarship. Wherever you see an opportunity, you apply. And more you apply, more are the chances you will get that particular opportunity, right? For example, in this campus, it's a huge campus, maybe there are 100 plus buildings. If I leave a book in a room in any of these buildings, and if I ask you under what situation there's a possibility that if you are going to explore that book or find that book, you will find it. What would be that case? That 100% you will be able to find that book. Anyone? If you go and visit all rooms, definitely you'll find it. It is in one of the rooms, right? So same applies here. More you apply, more you win. Okay, so wherever there's an opportunity, it doesn't matter whether you score 98%, Without extracurricular, I don't care. I care if you are good at doing practical things. 90% will work, 80% will work, but you should have a good curriculum experience. You should have like done some projects, real projects. So apply for scholarships, fellowships, wherever you see an opportunity. So for a young researcher, a scholarship, fellowship is worth 10 publications. This is more for PhD students, but this does apply to you. Like keep applying wherever you see an opportunity. That is very, very important. Research proposal, I will skip this one. Participation is very important. In any conference, see, networking in future, you will realize that networking is how important it is. You may be very hardworking student, but you will never be able to become a CEO until unless you don't know how to speak, how to network, how to connect with people, how to learn how to build collaborations. So wherever you see a conference or whatever opportunity, I understand at school levels there are not many such opportunities, but like an opportunity to be here today, you will be meeting the students from other schools, right? So that is very, very important because like meeting people outside your domain can bring a lot. Let me give an example. Lindau Nobel laureate meeting happens in Germany every year. Lindau is a place in Germany, and after World War II, when most of the scientists left Germany, this was an attempt to bring science back to the Germany. So they organized this meeting where the Nobel laureates are the only speakers, and the scientists of age up to 35 can attend this. Every year, DST, Department of Science and Tech, Government of India, calls those who are interested. Once you will be, I think after BSc or after BTech, you can apply, like after your undergrad. And I had an opportunity to meet Donna Strickland. She's the second Nobel laureate, third Nobel laureate, third woman Nobel laureate in physics. So she works in my area. I said, Madam, I want to visit your lab. I want to work with you. And there is another conference, Global Young Science Summit in Singapore. In this conference, they invite Nobel laureates, Millennium Technology Prize winner. Millennium Technology Prize winners are a bit different than the Nobel Prize ones. In Millennium Technology Prize is given in the area of technology, high-tech technology. And then comes the, so these are the speakers there. And again, the people up to age of 35 are the participants, basically. So let me show you the impact, basically. So I got the letter from Donna. Okay, you can come and visit. So just a one request there did the job. I couldn't go because of the COVID and all that. Okay, so what I'm trying to say, like wherever, it is very, very important. I have seen, like here, those who are very, very successful have very strong network. Without strong network, it's hard. It's hard to move, basically. Okay, so if you know the right people in the right place, that can make a lot of difference. And how will you build that network? You have to come out of your comfort zone. You have to come out of this social media. You need to interact with the people. And where will you interact? Where, it can be a meeting place, it can be a conference, it can be events, different events where you will participate. Some of you will be going to the colleges soon after finishing your classes. So participate, be a member of different clubs. Okay, that will help you and give you this opportunity to interact, meeting different people. Another example is like, this is one of our research paper. I'm just giving an example, like I know you are not writing research paper at this moment. So I was at Denmark, R. Siddharthan, which is was at Singapore. We met at a conference. We said, oh, I'm doing this. He said, I'm doing this. So let's collaborate. We can do this together. And this is the result of that. We developed the world's first ultra broadband superconducting light source. So if you wouldn't have met, we wouldn't have done that job, right? So some people try to misuse conferences. If you get an opportunity, usually I see in Indian community, it's very common. If you're going to Germany, then people start looking for the opportunities for sightseeing, visiting relatives, friends. That's very, 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 very common. That should not be the case. If you're going to any event, please, the programs are usually available online beforehand, right? You use your time wisely and try to attend as many as possible. Ask questions. That is very, very important. As I said, it's a very good learning I had from a Nobel Prize laureate, that if you ask questions, you will learn more. And okay, rest are basically for PhD students. E-connections are very, very important. If you can't go, if you can't travel because of XYZ reasons, maybe some disease is limiting you, maybe family problems, then just connect people with online. I have done that and we have been very successful in doing so. See, sometimes you just, for an internship, if you are looking for, you need one reply. If you write to 100 people, one might work, right? As I said, like, if you want to find the book in the room in this campus, you have to visit all possible rooms and that would work. So never feel shy in asking questions and connect people with through emails. Like when we were looking for positions abroad, a PhD position or master's thesis positions, we were just shooting emails basically, and that helps. And it is very, very important that you have your web presence nowadays. If you are doing something, marketing is very, very important, and you need to make sure community is aware of your work. So ResearchGate, OSA, LinkedIn groups are very important. You need to have a profile over LinkedIn, and you can use social media in any way. You are more smarter than me in using social media. And okay, we'll talk about, fine, we have discussed like what you can do or how can you prepare yourself to be a entrepreneur. And in this part, I will talk about engineering building the future. Like what are the problems that are upcoming problems that you need to solve basically, and what are the chaos that we have created on this planet and left things for you to solve basically. We are entering into AI, artificial intelligence. Everyone is talking about AI, 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 and but where is the hardware? So one thing is like learning AI. It's very, very important. Like in our parents, like my parents' generation, the computer and internet was introduced. Those who learned, they did well. Those who decided not to learn it, they didn't do well. For our generation, including yours, it is very important that we learn AI. AI has proved its impact, and it will be everywhere after 5 years. Doesn't matter whatever software you buy, whether you buy a washing machine, it will have AI installation. It is. So what is AI? I will little bit talk about it. Those who have good idea, that's fine. Those who don't have good idea, let me just little bit explain. So what happens? Let's say you have there's a kid, okay, and that kid don't have a brain as of now, like developed brain. So you give that kid some instruction, okay, take this road, then take a turn, right turn, that turn, that turn, then you reach to the shop, give 100 rupees note, take this and come back. Set of instruction. That person follows that set of instruction, okay. That is not intelligence. That is just like you ask them to do these things, that person will do that. But over a period of time, if I have accumulation of those instructions and output, okay, A is the input, C is the output. So these set of instructions are there. Then suppose I have been to that place or other place hundreds of times. I know, okay, I have to do this in this scenario. Then I can take a decision when I don't know what will happen in this case. Okay. So initially you train a model, you have input, you have output. So you are basically teaching a machine. Machine is learning itself. This is the input, this is the output. If this is the instruction, I have to do this. If this is the instruction, this has to be the output. But then after this has been trained, there will be inputs there are no solutions like right now. But based on that experience, machine can tell this is the output. Okay, that's the learning, machine learning basically. That's a part of AI. So that's a very basic example. It's like curve fitting. I'm sure you must be doing curve fitting in mathematics where you have some input, you have output, you try to fit into an equation. So it is something like that. And whole world is after AI, making these chatbots, etc. But where is the hardware? So you know the processors which we all use in our computers have millions of transistors. You must have heard of Moore's law. Like, but the amount of computation that AI demands, we are looking for the next generation hardware, which is a very key area that's very exciting, like developing new processors. The current processors will fail, current computers will fail to compute that much. So that's a very, very interesting area. Second interesting area that will emerge or already emerging is the cope up with the demand in the information age. As I already said, internet is fine. We are having the finest of internet, but it will not exist if we don't improve the infrastructure because the demand is increasing day by day. According to Huawei, by data generated by 2025 would be 180 zettabyte, okay, and that consumes maybe around 20% of the world's electricity. So we need to find the solutions where we can send the data through optical fiber at a lower cost without consuming much of the electricity. And by 2030, it would be like more than 200 zettabyte, and we would require 600 terawatt hours electricity. Also, a third thing is the quantum age, and I'm sure you must have heard of the quantum computers which are emerging. So what it does basically, I won't go into the detail, but those who are in class 11 and 12 must be studying quantum mechanics. And this is a technology based on quantum mechanics. And there are 4 pillars of quantum technology. One is quantum communication, one is quantum computing, third is quantum sensing, quantum imaging. In quantum communication, the thing is that what happens right now, we do free space communication. We send basically photons. In quantum communication, we have entangled photons. So two photons simultaneously will be generated and one will have information. If you change or if you try to steal information from one photon, another photon will learn. So it will be ultra secure communication. Quantum computers, they will be very, very fast. They are already very, very, very fast, and they can do the job which supercomputers will do in next 10 years, that quantum computers can solve in hours, basically. So that's the future. Quantum has still to prove its efficacy, whether it is really going to be a household technology in future. But AI has already proved its innovation, okay, its impact, basically. Fourth thing, which is a great challenge, is the climate, right? You all know about Paris Agreement and all that, okay, we'll reduce CO2 emission. So if you are looking for solutions in that area, how we can reduce our CO2 emission, that would be really, really good. Okay, I will talk about these in little bit detail, like quantum tech. So it is an emerging technology. Government of India recently announced National Quantum Mission, where IIT Delhi is also one of the participants. And we are also doing some research in that area. So it's more about like communication, computing, as I said, and I won't go into detail, that will be too much technical. Second part, AI, I already discussed, neural networks. So AI is something which you can start learning now, fairly simple, if you know basics of programming, or at least read about it. It is very, very important. I was talking about the hardwares. So companies in the Western world have started building the photonics chips. This is a second generation optical computer based on photonics. So last century was about electronics. Almost everything is electronics. If you see, like processors are electronics, where electrons move, okay, and forms the current. But as you know, Moore's law is ending. Moore's law was like number of transistors on a chip will double at every year. But now we have reached to a stage where we cannot double the transistors anymore. So now the future is about photonics. 21st century is about photonics, where we use light. Okay, already as I mentioned in the beginning of the lecture, we are using light for communication. Optical fibers has a light, basically. So now idea is to use light for computing as well in matrix processing form. Why light above electron? Because light can be much, much faster. Light travels with the speed of light, 310⁸ meters per second. And when two photon moves, they don't interact with each other. Two electrons interact with each other. So through same fiber or wire, you cannot have the current flowing in two directions, right? But through a waveguide, through a fiber, you can have light flowing in different direction. So it can be possible because two photons don't interact with each other. That's very, very important. That makes photonics computing. Light is made up of photons, right? Quantized form of light is photons. And this area is known as the photonics, like electronics. So in future, no wonders, you might have the photonics processors in your computer. They can be much, much faster. So this is a new field, emerging field. As I said, like it's a second generation optical computer that you can see right now on your screen. And if you see the impact, the phase shift solved some NP cut problems. If you're aware of NP cut problems, maybe you can Google about that. I won't go into detail. So it solves in 154 microsecond, while it takes 18,000 microsecond if you solve with the current state of the art GPUs. That's much, much better. Another interesting area where you can think of exploring is the net zero emissions. Hydrogen is the future. Anyone having any idea about why hydrogen is being considered as the future? Yes, please. Yes, please. Go ahead. Oxygen and? So no CO2 emission. Hydrogen plus O2, H2O, right? And we want to just make the net zero emissions, means we don't want to emit CO2 anymore. There's a lot of discussion going on that, and there's a new field emerging, carbon dating. It's like in Western world, there's a restriction how much CO2 as a business owner you can emit. And if you want to emit more, you have to take it on credit from other business unit which is emitting less. Okay, so they have made it constant. More than this much CO2 we cannot emit. So the future is about hydrogen. Hydrogen is a lightest element, as we know. Okay, and high calorific value. It doesn't emit any CO2. But there are problems with hydrogen. It's an odorless gas. It's a colorless gas. Okay, so there are a lot of risks associated with hydrogen while its storage, transportation. For example, if we have a gas pipeline which allows transportation of methane, okay, but the same line will not allow the transportation of hydrogen, because hydrogen is so small that the orifices in the gas pipeline which are okay for methane, but they are like too loose for hydrogen, and hydrogen will come out of that. So that's the big problem. So right now, if you can solve the hydrogen storage and you can use the hydrogen in a controlled way for a number of applications, then you can be perhaps billionaire. So that's the very, very key area where you can think of exploring. Another important area is circular economy, recycling. That's a serious danger. Okay, e-waste, electronic waste, basically, that's a serious waste. Space debris. Right now, you would be surprised to know that there are more failed satellites around the Earth than the live ones. Okay, so this is something how our Earth looks like. And of course, the landfills, that's a serious problem. This is the problem that we have left for you people to solve, basically. Okay, another interesting area is the e-vehicles. By next 10-15 years, all these petrol, diesel cars will run away. We'll have the e-vehicles. The problem with the e-vehicles is the batteries. Okay, lithium-ion batteries, their interconnections. This is where optics comes into the picture. Okay, so these are some areas: e-vehicles, circular economy, net zero emissions, photonics, where you have the faster processor, faster data communication, AI, and the quantum tech. These are the areas where most of you will be working. So it's a good time if you want to start learning at least some part of that. Okay, in the last part, I will talk about some generic advices. So see, you are the future of this country. If you see the average age by countries, India is youngest country. The average median age here is 28.7. And you're not just the consumer of the future, you are its creator. So every second counts. Age is just a number, age is not just a number. This might be very confusing, right? So in Western world, there is a saying that age is not just a number. You can start learning anything at any point of time. Okay, so that's very, very good. But it doesn't mean that you waste your time, right? Okay, I can do age is just a number. I can start doing things at the age of 30. I can start doing things at the age of 40. So I would give an example where Obama completed his 2 terms as a president before the age of 60, and now he's enjoying. While, okay, Joe Biden was president in his late 70s, he had a lot of trouble, right, with his health. So what I'm trying to say is time is very, very important. Use your time wisely, okay? And it's okay if you fail, if you feel that you didn't get the right directions, you couldn't make best out of your time, it's okay. There's always, like, you can reboot your system, reboot your life, you can start new life, but it doesn't mean that you waste your time. So every second counts. You know who said this? Every second counts? Anyone? I forgot the name, the person, he's a cyclist, okay? So he mentioned this one, I forgot his name. So that is very, very important. So in life it matters, basically, how you are spending your days, what you are learning, what you are not learning. And as I said, it's just a number. If you feel, okay, you didn't do well, but it's okay, you can reboot your life, you can start at any point. But it matters, it is very, very important. Second thing is never give up, keep trying, keep trying. As I said, like, this is the time where you will be facing a lot of troubles, a lot of exams, a lot of competitive tests. So don't give up. If you don't clear JEE, that's fine. Try for some other school, okay? Try for GATE, okay, I will do masters from IIT, if not undergrad. Go abroad or wherever, like, learn. But don't give up. See, if you cannot fight, you cannot get good things. You have to fight. Good things won't come on your own. And you have to do this process continuously, continuously, continuously. And as an inventor, if you're looking for a career in this area, you are meant to solve the toughest problems, okay? And if you have to solve the toughest problem, you have to be tough. You have to keep trying. See, in life, accumulative hard work matters, believe me. Like, if you keep putting efforts, maybe one day it will help you. Life is not a piece of cake, okay? So just to give you an example, like when we raise money, it's very, very difficult for our research. Like we have to write a lot of research proposals, and sometimes you spending whole night. Maybe like suppose the deadline is 20th of July, you start working from 1st of August or 1st of June, and over the 50 days you will be writing your proposal a number of times, and it may fail. It may take just 5 minutes for the funding agency to say no, fine. Okay, but it doesn't mean that you'll stop applying. You have to keep applying, keep applying, keep applying. At the end, it doesn't matter how many times you applied. What matters is that how many projects you got, how much money you have raised. So this is very, very important. Life is not a piece of cake. Okay, remember. And one more example of when it comes to JE. So one of my colleague, I asked him like he cleared JE and he was BTech from IIT Kanpur. What made you to clear JE? He said my elder brother was also preparing for JE, and he didn't clear, but he told me one thing: Shalabh, these problems are being made by men, right? Someone is creating this problem. You can solve these problems yourself. So keep in that if it's a man-made problem, it can be solved. So he said, I thought, okay, I won't look at the solution. I will keep solving, trying. Like sometimes a single problem may take few days, but he was able to solve it. Slowly, time was improved. So that's the important thing, that always remember there are some problems which you cannot solve, which are not man-made, but man-made problems can be solved. Okay, as Stephen Hawking always said, there should be no boundaries to the human efforts. All are different. Okay. If you want to change the world, you have to be at your brightest, at your darkest. Always remember that. Okay. If you want to be leader, everyone wants to be leader. Everyone wants to be like on TV. Everyone wants to be billionaire. But you have to be different, right? If you want to change the world, you have to be at your brightest, at your darkest. So what does it mean? Like even while you are going through toughest, you have to be bright. You have to work hard. You have to believe in yourself, and you have to keep trying. Okay, some advices or some learning which I had from Nobel laureates during my interaction. So Professor Claude Cohen, and he won Nobel Prize in 1997 for laser cooling. And he said, if you want to be master of something, teach this. Okay, if you teach something, you will continuously learn, being a student, and you will be master of that. So this is what I try. Like every semester, I try to take a new subject which is tougher than the previous one, because if I won't read myself, but if there's a lecture tomorrow morning, I have to finish the slides. Yesterday night, I finished the slides by 2 a.m. because I knew this morning I have a lecture. Okay. So Hiroshi Amano, he was a Nobel Prize. I talked about the LEDs, light emitting diodes. Keep trying until you succeed. Okay. When he was growing gallium nitride, optical quality gallium nitride for blue light emitting diode, it took more than 500 attempts basically. So you have to try. That's it. And that's the only difference between those who are successful or those who are not successful. As I gave you myself an example, like those who clear JE, they have the perseverance, they have that threshold. Those who they don't have. So another from Sir Timothy Hunt: ask questions. It doesn't cost you anything, right? There's no harm in asking questions. And there's another Nobel laureate, William Philip, from US in 1997. He won the Nobel Prize in Physics. Call me Bill. We used to address him sir, like though it's not part of Indian culture, but we have colonial legacy. One of the big reasons why we are not successful, because of this colonial hierarchy in our system. Sir, madam. In Western world, it's very common to call by the first name. We all are scientific colleague. I addressed him sir. He said, no, call me Bill. We are all your scientific colleague. And okay, I won't talk about that David Payne because it's more for the professors. What makes a good PhD student, inventor, or scientist? Like curious, ask question. As I already said, optimism is very, very important. If you are not optimistic, you cannot be a good scientist. If you are solving unsolved problems, toughest of the problem, you have to be very optimistic. You have to believe that it will work. You have to keep trying. Reader, that is very, very important. See, until unless you don't know what is the current state of the art, you won't be able to make the improvement, right? If I want to make a new satellite, I need to know how the current satellite works, right? For that, I need to read. If you want to be visionary, you need to know the problems, existing problems. If you want know about the hydrogen things, what is happening in the world. So you have to be a very good reader. If you want to be good PhD students, I usually say to my student that you read 2 good papers, basically research papers. And as a school students, you can read anything, but read it. because more you know, more would be like being innovative is directly proportional to visionary, and being visionary is directly proportional to the reader. And how good are you, the reader? Okay. Develop writing skills. I've already talked about that, so I will just skip this one. Move to 2G phones. Believe me, if you want to do really good with your life, move to 2G phones. Okay, let me give you an example. When I was doing my PhD, I had 2G phone with me. And once I was talking to a friend in India, he said, "Are you on WhatsApp?" I said, "What is WhatsApp?" Being very honest, I could focus a lot better on my research afterwards because of XYZ reasons. Now I have 4G or 5G, whatever. So if possible in school life, move to 2G phones. Okay, why to be unpaid employee of Mark Zuckerberg? This is a trap. This is a trap to destroy the upcoming generation, basically. And keep learning new skills. It's very common that we all enter into our comfort zone, then we don't learn new skills. So it's very, very important that you learn new skills. Be a team player. And it's very important in future. You cannot do everything alone. You need to be a team player. You need to learn how to be a team player, how you can work with others irrespective of the differences. You know this person has this problem, but still you need to know how to work this person. Okay? And keep doing small things. One success will bring another. Let's say this year you are participating in something. You may not be able to win it, but next year with some feedback, you try again, you may be able to win that particular competition. Rome was not built in a day. It takes some time to build your CV, basically. Okay. So as I said, like one will bring another, another will bring another. So keep putting efforts, find your collaborators, team people with whom you can do something. Be with energetic and ambitious people. That's very, very true. If you're not with energetic and ambitious people, you won't be able to do well. Find your role models. That is very important. Last but not the least, motivation. That's very, very, very important, right? So watch these movies, and I'm sure that you will feel good about it. These are all great movies about science, tech, biopics, and that will keep you motivated. And whenever you feel frustrated, you can watch them. I usually do that whenever I feel frustrated. And at the end, thank you. Thanks. And if you have any feedback for this lecture, you can please feel free.
So I have a beautiful quote before we end the conversation. So life is full of twists and turns, and every one of us sometimes hurts. Don't give up. When the pace is low, you will succeed in another one, in another one. And we live with this, our life in the party. With wisdom and with passion, you showed up love. You made us think, you made us learn. Every word, our hearts. Do you have any doubts, any questions you want to ask also? Any query? It is truly an honor and a privilege to stand here today to express our deepest gratitude to Professor
questions.
Jain for taking time out of his busy schedule to be with us and to share your valuable insights with us. Your lecture today was not just informative, but truly inspiring. Your words of wisdom has enlightened every one of us. As a token of respect and appreciation, we would now like to present you with a moment. This is not just a symbol of today's event, but a heartfelt thanks to you for your generous contribution to the academic community. May I request Gaurav sir, in the meeting, please? I now take the opportunity to all attendees for being an honor to be part of such a brilliant and powerful conference. A special thank to everyone present here for listening me patiently. With this, I, Shivani Ghosh, take your leave from the stage and leave you all with a beautiful quote. The woods are lovely, dark and deep, but I have promises to keep and miles to go before I sleep, before I sleep. With that, our next Sci-Tech Lecture Spins is scheduled on 30th July from 10 to 11:30 a.m. by Professor Anushri Malik on the topic Dying Nexus, Breaking Through Smart and iSmart. So stay tuned for the next lecture series, which is on 30th June. Soon I'll be sending you the invitation for the same. Dear students, we have a feedback form. Dear students, we have a feedback form which I have already circulated to all the coordinators. I would request you to meet you and share us your feedback for this lecture latest by Monday, probably by 5 p.m. We would be honored to have your feedbacks. With that, I would now love to show you a slide where there's a QR code. You can scan it out and see get your feedbacks there. So, children, if you have any questions, feel free to connect the campus outreach to the newspaper office. We are just a phone call away. You can call us, you can post, you can give us anything like you want to have your questions related to your future